Welcome to AP Stats, Quideo number 5. This is the pre-inference unit, and this question is asking us to construct a 99% confidence interval for the proportion of vaccine-eligible people who actually had received that vaccination, and to use that to comment on that belief that 45% of the vaccine-eligible people had received the flu vaccination. So when we talk about confidence intervals, we normally reference this page. It's about our PANTS acronym. For P, when you're constructing your confidence interval, you're supposed to address the parameter of interest. And for this problem, the parameter of interest would be the proportion of vaccine-eligible people who received the flu vaccination, which is going to be 978 out of 2,350. That parameter ends up helping us get our p-hat value. The second thing that we always do when we are constructing a confidence interval is in the A part of the PANTS acronym, which stands for assumptions. And basically that's just using those two rules of thumb that are in a textbook and that we use a lot in class. The first one is just making sure that our sample is small enough. So if we took our sample number, which is 2,350 United States citizens who are vaccine eligible, and you multiply that by 10 just to make sure that your population is at least 10 times the size of your sample. So we can infer that over 2,350 people are vaccination eligible in the United States. And then rule of thumb number 2 is just to make sure that your sample is large enough. You would just take n times p, so our n value is our population, and then our p value is 45, because they said in the problem that 45% of vaccine-eligible people had received the flu vaccination. So that's where we got that, and you just have to make sure that that is going to be greater than or equal to 10, which it is. And then you also have to do n times q, which is basically, again, the sample size, and then you multiply it by the not p-value, which is going to be 55, because 55 plus 45 equals 100. So you're going to take those two, multiply them together, and you get 129,250, which obviously is greater than or equal to 10, so it passes that rule as well. So now we know that the sample is both small enough and large enough. And then lastly, we can also conclude that it is a random sample because it does say so in the question. The N part of constructing a confidence interval is naming your confidence interval. And so for this one, we would use 1 proportion Z interval. And we know that we use this because it is using the proportion of people who get the flu vaccination and people who don't, of people who are eligible to receive it. So you are using 1 proportion, you aren't using multiple. So I just have that written down here. We have, this is what's in your calculator. So we have 1 minus prop z interval, and then the equation that you use for this is p hat plus or minus z star times the square root of p times 1 minus p over n. The T part of constructing a confidence interval asks you to plug everything in and test a statistic, so that is what I did here. I plugged everything in, so we have our 0.41617, which we got. That's our p-hat value, and that's basically just dividing the number of people who did receive the flu vaccination, and dividing that by the total sample population, which was 2,350, like we discussed before. So that's your p-hat value. And then it's plus or minus z star, and we get our z star value from the z chart in our textbook. So I looked that up, and it's 2.576 times the square root of p times 1 minus p over n, and our p-hat value is, again, 0.41617 times 1 minus p, which is 0.58383, over our n value, which is our sample, and it's 2,350. And while you're plugging things in, you keep this p-hat value, but once you get to this z star value times p times 1 minus p, or the square root of p times 1 minus p over n, this is going to be your margin of error right here. So I solved that here, and this is one extension that you can make, is that the margin of error is going to be 0.02619. Once you plug it all in, obviously the plus, when it's plus or minus and you use plus, it's going to be your upper bound, and when you use minus, it's going to be your lower bound. So when you do that, your lower bound is going to be 0.38998 and your upper bound is going to be 0.44236. And then the last part of what you need to do when you are constructing a confidence interval is to put your statement in context. So my statement is that we are 99% sure that the true proportion of vaccine eligible people who actually receive that flu shot is between 0.03998 and 0.44236. Part B is kind of similar to Part A. It's saying that the same thing basically happens in Canada by Canadian health officials, and it says 99% confidence interval for the proportion of people who will receive the flu vaccination is to be constructed. And it says, what is the smallest sample size that can be used to guarantee that the margin of error will be less than or equal to 0.02? So if they want our margin of error to be less than or equal to 0.02, we can manipulate that in our own little equation. So here we have our margin of error, so 0.02, which should be greater than or equal to our critical z-value, which we already used from before, 2.576. And then using that same equation that we had again earlier. And since they didn't give us a specific sample size, we just need to estimate, and the best number to use for that is going to be 0.5 because you have a 50-50 chance of them having received that vaccination if they are vaccine eligible. So that's why we would just use 0.5 instead. And then for your answer, you get 4,144.14, so that is the sample size that they should aim for.